Hi and greeting everyone. In this video, my group member and I will present about frictional loss in pipe experiment. Our group member consists of me, Dr. Akila, Muhammad Hafiq Al-Firdaus, Navik Resbelina Logius, and Awangku Irene. So I will start with introduction. This experiment is to study frictional loss in pipe caused by friction change in velocity or direction of flow. When an incompressible fluid flows through pipes, bands, valve, and other pipe flow measurement device, frictional head loss will occur. Frictional head loss in straight pipe of different size can be studied with a range of a Reynolds number. The friction factor depends on the Reynolds number of the flow and the relative roughness of the pipe. In this experiment, the Cousin P6221 loss and pipe and fitting apparatus was used. It is a fluid friction measuring device specially designed to enable detailed study of friction head loss. It comprised pipe with a nominal diameter 7 mm and 10 mm, each having two static pressure points spaced 360 mm apart and 464 mm in length. The T-section was installed between the P6103 constant head tank and the P6104 variable head outlet tank. The head loss across the section of the tube was measured using the P6106 manometer port. Laminar flow occurs when fluid moves in smooth parallel layer with faster motion at the center of pipe. At higher speed, the turbulent flow arises where chaotic motion enhances mixing. In turbulent flow, the friction factor depends on Reynolds number and pipe roughness, but for fully turbulent flow, it only depends on roughness. The Moody's chart is commonly used to determine friction factor. Understanding how head loss relates to pipe diameter at a constant flow rate is essential for selecting the right pipe size. There is two objectives in this experiment. First, to investigate friction loss due to friction in pipe. Second, to compare relationship between friction factor and Reynolds number with empirical data.
Now, I will explain the methodology used in this experiment. The equipment and instrument used are listed, and each of them play an important role in obtaining accurate measurements. First, we have the pump speed display. This device is used to measure the speed of the pump during operation. Second is pump speed control. This component allows us to control the speed of the pump manually, so we can set it to different flow conditions as required. The third instrument is the manometer. It is used to measure and record the pressure at the inlet and outlet points. Then, we use the hydraulic bench. This is essential to determine the volume flow rate of the fluid during the experiment. Finally, the rotometer. It measures the flow rate by calculating the time taken to collect a fixed volume of water. This helps us to get direct reading of the fluid flow rate. Now, let me explain the procedure. First, we use a smooth pipe. The rotometer was adjusted until the flow rate was steady. Next, the hydraulic bench was controlled and the stopwatch was started once water collection began. Then, we collect 5 liters of water and recorded the time taken. This step was repeated at flow rates of 0.6 and 0.4 cubic meter per hour to ensure accuracy. We repeated the same step using the raw pipe at flow rate of 1, 0.6 and 0.4 cubic meter per hour and recorded the value for each.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Fidas bin Madin and my matrix number is EK24110014 and I will take in charge in result discussion of experiment B. And this is the result of our experiments. Smooth pipe table on the left and rough pipe table on the right. We use volume flow rate as our variable manipulated with the same water temperature, density, viscosity, test section diameter, and length of pipe. We use 16.6667 liter per minute, 10 liter per minute, and 6.6667 liter per minute. The data in both tables shown that the Reynolds number decreasing when the friction factor increasing. And this is an analysis I made. Graph of ln H against ln V for both type of pipe. According in figure 1, we can see that the relationship in smooth pipe is linear and the relationship in figure 2, which is rough pipe, is polynomial. Let's move on to the discussions. Based on the result, smooth pipe table show that friction factor and Reynolds number follow the power law relationships because Reynolds number decrease as the friction factor increase. So the data follow the expected trend for a smooth pipe in turbulent condition because the Reynolds number over 4000. So this is already show the inverse relationship between friction factor and Reynolds number. According in rough pipe table, the relationship between friction factor and Reynolds number show the same trend as the smooth pipe. Even the Reynolds number in rough pipe is smaller than the Reynolds number in smooth pipe with the same quantity of variable manipulated, which is volumetric flow rate. The data still show the same relationship between friction factor and Reynolds number. So this is already reached our objective to find the relationship between Reynolds number and friction factor. And based on the analysis, figure 1, which is smooth pipe, show the linear relationship between ln H and ln V. So the relationship is direct relationship. As we know, friction at loss is depends on the pressure at loss, and pressure at loss is inversely relationship with mean velocity. So the friction cause a velocity decrease and increasing the pressure. According figure 2, which is rough pipe, the graph show the difference relationship between ln H and ln V. The graph is not linear but polynomial. This is because the flow condition in the rough pipe is unsteady state, so the friction is roughly. The experimental error in this experiment is there is leaking at surface of pipe, so the pressure in pipe is interrupted by pressure of atmosphere and environment. So the velocity and volume flow rate is not accurate as possible. That's all from me, and we move on to conclusion with Irene. Thank you.
Okay, now on to the next part, the conclusion. In conclusion, as friction increases within a pipe, the pressure loss will also increase. This is because friction reduces the velocity of the fluid flowing through the pipe, which according to Bernoulli's principle leads to a decrease in pressure. From the results of the experiment, we observed that when the velocity of the fluid in the pipe decreases, the friction head loss also decreases. This suggests that friction, which typically reduces fluid velocity, also contributes to lowering the pressure loss. Additionally, the experiment shows that as the Reynolds number decreases, the friction factor increases. This indicates that the Reynolds number is inversely proportional to the friction factor. That is all from us all. Thank you.